Welcome to MindTier Learning, where we make GCSE learning and revision simple. Throughout this session, we'll explore effective strategies and tips to help you prepare confidently for your exams. Let's get started on this journey to mastering your GCSEs. Welcome to today's lesson on transportation and deposition. In the last lesson, we looked at how rivers erode the landscape. We learned that rivers can wear away the bed and banks through processes such as hydraulic action, abrasion, attrition, and solution. But once a river has eroded material, an important question follows. What happens to that material next? The answer is that the river transports it downstream. A river does not just carry water. It also carries a load. This load can include huge boulders, small pebbles, sand, silt, clay, and dissolved minerals. Some of this material rolls along the riverbed. Some bounces. Some is carried within the water. Some is dissolved and cannot be seen at all. Eventually, when the river loses energy, it can no longer carry all of this material, so it drops it. This process is called deposition. Today we are going to look at how rivers move their load, why they drop it, and how velocity controls what a river can erode, transport, and deposit. The big question for today is, how does a river move material from the mountains to the sea? Let's begin with our learning objectives. By the end of this lesson, you should be able to do 3 things. First, you should be able to explain the 4 main methods of river transportation. These are traction, saltation, suspension, and solution. You need to know which type of material each process moves and how that movement happens. Second, you should be able to understand why rivers deposit their load. Deposition happens when a river loses energy. We will look at the reasons this might happen, such as a reduction in gradient, a fall in discharge, or the river entering a lake or the sea. Third, you should be able to analyze the relationship between velocity and particle size using the Hjulström curve. The Hjulström curve shows how different river speeds affect whether particles are eroded, transported, or deposited. By the end of the lesson, you should understand that river transportation and deposition are controlled by energy. When energy is high, rivers can carry more. When energy falls, rivers drop their load. Before we go further, let's go through the key vocabulary. The first term is traction. Traction is when large boulders and rocks are rolled along the riverbed. This happens when the river has enough energy to move heavy material, but not enough energy to lift it into the water. The second term is saltation. Saltation is when small pebbles and stones bounce, or hop, along the riverbed. The river lifts them briefly, they fall back down, and then they are lifted again. The third term is suspension. Suspension is when fine, light material, such as silt and clay, is carried within the water. This can make river water look brown or murky. The fourth term is deposition. Deposition is the process of the river dropping its load when energy levels fall. We will also mention solution, which is when dissolved minerals are carried invisibly in the water. These terms are really important because they help you explain how different sizes of sediment move through a river system. Before a river can move material, it usually has to create or collect that material. In the previous lesson, we looked at the 4 main erosion processes. The first was hydraulic action. This is the force of the water breaking apart the riverbed and banks. The second was abrasion. This is when rocks and sediment carried by the river scrape against the bed and banks like sandpaper. The third was attrition. This is when rocks carried by the river collide with each other, becoming smaller, smoother, and rounder. The fourth was solution. This is when slightly acidic water dissolves soluble rocks and minerals. These erosion processes create and change the river's load. Once material has been broken away, the river can transport it downstream. So erosion and transportation are closely linked. Erosion produces material. Transportation moves it. Deposition drops it. Let's do a quick recall from the previous lesson. Question 1. Which process involves rocks smashing against each other to become smaller and rounder? Question 2. What do we call the process where minerals, such as calcium carbonate, are dissolved in the water? Question 3. Which type of erosion involves the sheer force of water trapping air in cracks? Take a moment to think. Remember, one process changes the shape of the load, one process is chemical, and one process uses the force of the water itself. Let's go through the answers. For question 1, the answer is attrition. Attrition is when rocks collide with each other and become smaller, smoother and rounder. For question 2, the answer is solution. Solution is when minerals are dissolved in the water and carried away. For question 3, the answer is hydraulic action. Hydraulic action happens when the force of water traps and compresses air in cracks, helping to break rock apart. These processes matter because they help create the load that rivers then transport downstream. Now let's think about the river's journey. The slide asks an interesting question. Where does a mountain go? Over very long periods of time, rivers can transport huge amounts of rock and sediment from upland areas down towards the sea. Mountains are slowly weathered and eroded. Rivers collect that material and move it through the landscape. But how can a river, which is just liquid water, move a boulder the size of a microwave? The answer depends on two things: the size of the load and the energy of the water. Large, heavy material needs a lot of energy to move. Small, light material can be moved much more easily. A powerful river during a flood may be able to roll large boulders along the riverbed. A calmer river may only be able to carry fine silt or dissolved minerals. So the key point is, the method of transport depends on the size of the sediment and the energy of the river. Now let's look at the 4 main methods of river transportation. The first method is traction. Traction moves the heaviest material. Large rocks and boulders are rolled along the riverbed. This usually happens in high-energy conditions, such as the upper course or during floods. The second method is saltation. Saltation moves smaller pebbles and stones. These particles bounce or hop along the riverbed. They are lifted briefly by the water, then fall back down, then lift again. The third method is suspension. Suspension carries fine, light material within the water. This includes silt and clay. When a river looks muddy or brown, it is often carrying lots of suspended sediment. The fourth method is solution. Solution carries dissolved minerals in the water. You cannot usually see this material because it is dissolved. The important thing is that different sizes of material move in different ways. Large boulders roll, pebbles bounce, fine sediment floats. Dissolved minerals travel invisibly in the water. Now we need to understand 2 important words: competence and capacity. A river's competence is the maximum size of load it can carry. For example, if a river can move large boulders, it has high competence. A river's capacity is the total amount of load it can carry. For example, a river carrying huge quantities of sand, silt, and gravel has high capacity. Both competence and capacity are controlled mainly by velocity. Velocity means the speed of the river. If a river flows faster, it has more energy. That means it can usually carry larger particles and a greater total amount of sediment. This is why floods are so powerful. During a flood, water volume and speed increase. The river may be able to move material that would normally stay on the bed. Velocity is often highest when a river channel is deep and smooth because there is less friction slowing the water down. So remember, higher velocity means greater competence and greater capacity. Now let's match the transport methods to their definitions. The transport methods are 1. Traction, 2. Suspension, 3. Solution, 4. Saltation. The definitions are: A. Light sediment like silt held within the water. B. Large heavy boulders rolled along the riverbed. C. Small pebbles bounced along the riverbed. D. Dissolved chemicals and minerals carried in the water. Take a moment to match them. Think about the size of the material. Which process moves the largest material? Which process carries material invisibly? Which process makes muddy water? Let's go through the answers. Traction matches with B. Large heavy boulders rolled along the riverbed. Suspension matches with A. Light sediment like silt held within the water. Solution matches with D. Dissolved chemicals and minerals carried in the water. Saltation matches with C. Small pebbles bounced along the riverbed. This is a useful set of definitions to memorize for GCSE Geography. A simple way to remember them is: traction rolls, saltation bounces, suspension floats, solution dissolves. Now let's look at deposition. Deposition happens when a river loses energy and can no longer carry its load. When energy falls, the river must drop some of the material it is carrying. The heaviest material is dropped first because it needs the most energy to be transported. There are several reasons why a river might lose energy. One reason is a reduced gradient. If the land becomes flatter, the river may slow down. Another reason is lower water volume. During dry periods or droughts, discharge may fall, so the river has less energy. A third reason is when the river enters a lake or the sea. As the river enters standing water, its velocity drops sharply, so deposition occurs. Deposition is very important because it creates landforms. For example, deposition helps form floodplains, levees, and deltas. So erosion shapes the river channel. Transportation moves the load, and deposition builds new landforms. Now we are going to introduce the Hjulström curve. The Hjulström curve is a graph that shows the relationship between river velocity and particle size. It helps us understand whether particles will be eroded, transported, or deposited. In simple terms, the graph shows that different sized particles need different river speeds to move. Large boulders need high velocity to be eroded and transported because they are heavy. Sand is easier to erode than clay because sand grains are loose. Clay is very fine, but it is also cohesive. That means the particles stick together. Because of this, clay can require surprisingly high velocities to erode. Once material is already being carried, it may stay in transport at lower velocities than were needed to erode it in the first place. This is why the Hjulström curve is useful. It shows that river behavior is not just about big particles are hard and small particles are easy. The relationship is more complex. Now let's think about deposition order. The question is, when a river slows down, in what order does it drop its load, from heaviest to lightest? The options are pebbles and gravel, large boulders, sand, silt and clay. Think carefully. When the river loses energy, which particles can it no longer carry first? The largest and heaviest material needs the most energy to transport, so that should be dropped first. The smallest and lightest material can stay in the water for much longer, so it is dropped last. The correct order is: first, large boulders; second, pebbles and gravel; third, sand; fourth, silt and clay. This is because the largest and heaviest material needs the most energy to transport. As velocity falls, the river loses the ability to carry boulders first. If it slows further, it deposits pebbles and gravel. Then it deposits sand. The finest material, such as silt and clay, can remain suspended in the water for longer and is deposited last. This sorting of sediment is important in many river landforms. For example, levees form because heavier material is deposited close to the river channel during flooding, while finer material is carried further across the floodplain. Now let's apply the key ideas. The question is, a river flows steadily. A massive storm doubles water volume and speed. Using competence and the Hjulström curve, what happens to the riverbed? First, if water volume and speed increase, the river's energy increases. This means the river's velocity is higher. If velocity increases, the river's competence increases. It can move larger particles than before. Its capacity also increases. It can carry more total load. So material that was previously sitting on the riverbed may be picked up and transported. Existing bed deposits, such as sand, gravel, or even larger stones, may be cleared away. The river may also erode more strongly. Depending on the channel and landscape, this could increase vertical erosion or lateral erosion. During a storm, the river is therefore not just carrying more water. It is also more powerful and more capable of reshaping its bed and banks. You might have said that the river's energy and velocity will increase significantly. That is correct. You might also have said that the river's competence will rise, allowing it to transport larger boulders. That is also correct. If the river has more speed and power, it may remove existing deposits from the riverbed. This can expose the bed to more erosion. You might also have said that increased energy could lead to more vertical or lateral erosion. A strong GCSE answer might say, if a storm doubles the river's volume and speed, the river's velocity and energy increase. This increases its competence, meaning it can transport larger particles, and its capacity, meaning it can carry more total load. Material that was previously deposited on the riverbed may be picked up and transported. The higher energy may also increase erosion of the bed and banks. That answer is strong because it uses the key terms competence, capacity, velocity, and erosion. Let's finish by bringing everything together. Today we have looked at two major river processes: transportation and deposition. Transportation is how a river moves its load downstream. There are four main methods. Traction is when large boulders roll along the riverbed. Saltation is when smaller pebbles bounce along the riverbed. Suspension is when fine material floats within the water. Solution is when dissolved minerals are carried invisibly in the water. Deposition happens when velocity drops and the river loses energy. When this happens, the river drops the heaviest material first. Large boulders are deposited first, then pebbles and gravel, then sand, and finally silt and clay. Deposition creates important river landforms, including floodplains, levees, and deltas. The key idea is that rivers are constantly balancing energy and load. When they have enough energy, they transport. When they lose energy, they deposit. That balance is what shapes river landscapes from source to sea. Thanks for watching. If you found this presentation helpful, don't forget to like the video and subscribe to our channel for more content like this. Your support means a lot and helps us keep creating valuable information for you. See you next time.